Good morning. Last class we had discussed problem on DIT FFT for 4 point, and at the same time I had shown you the signal flow graph for 8 point. So this is your 8 point signal flow graph. This is stage 0, stage 1, 2 and 3. So it is according to the butterfly diagram. Okay, so the stage 1 is very easy. Stage 2, you have to join the first line to the third line, second line to the fourth line, and fifth line to seventh line, sixth line to eighth line. So this is 1x with W80 and minus 1, WNR and minus 1. This is second x, minus 1, W82. Now, again, this is 1x, this is second x with W80 as an entry point for this, and W82, minus 1, minus 1. So its output will be, this is small x, the input will be bit reverse order, and the output will be a natural number. Okay, so this is small x, capital X. So you know that DFT of x of n is capital X of k, right? Now similarly, this is x2 of 0, x2 of 1, x2 of 2, x2 of 3, x2 of 4, x2 of 5, x2 of 6, x2 of 7. And here, these will be the inputs for stage 2. Similarly, looking at this part, for stage 3, these will be the inputs. Now, in order to draw the stage 3, you have to join first to fifth line, second to sixth line, third to seventh, fourth to 8. So look at here. This is 1x, right? Now with an entry of W0 and minus 1. This is second x, W81 minus 1. This is third x. Here, this from here till here. So it is W82, W84. So W80, W81, W82, W84. Rest are all 4, minus 1. So this is what you have to draw the butterfly structure or the signal flow graph for 8 point. These all points should be covered when you are drawing or when you are getting this problem. And the equations. If you know how to solve the equations, or if you know how to write the equations for n is equal to 4 point, then it is very easy to write the equations for 8 point also. So in order to get x1 of 0, looking at this part, a plus b, it is a plus b into this WNR. So it is similarly x1 of 0 can be written as x of 0 plus x of 4 into W80, which this is what you can see. x1 of 1 is x of 0, x1 of 1 is x of 0 minus x of 4 into W80. So here are the relevant equations for stage 1 and stage 2. Let's look at x2 of 0. So you are getting x1 of 0 plus you are getting x1 of 2 into W80. Now try to write the end of this, x2 of 0 and x2 of 2. So x2 of 2 can be written as x1 of 0 minus x1 of 2 into W80. So you can check it out. x2 of 2 was x1 of 0 minus x1 of 2 into W80. So in similar way you can write the equations for stage 2 also. Again stage 3. So for x3 of 0, you are going to write x2 of 0 plus x2 of 4 into W80. And in order to write x3 of 4, it is, you just need to change the minus sign over here. You can see x2 of 0 plus x2 of 4 into W0. For x2 of 4 it is x2 of 0 minus x2 of 2 of 4 W0. So in a similar way you can write the output equation for stage 3. Let's look at a problem on 8 point. Find the 8 point DFT of the sequence x of n is equal to 1 1 1 1 0 0 0 0 by using DIT FFT radix 2 algorithm. So this is the same structure what we have seen. So here, as I say, the input will be bit reverse: x of 0, x of 4, x of 2, x of 6, x of 1, x of 5 and x of 3. So x of 0 is 1, x of 0 is 1, x of 1 is 1, x of 2 is 1, x of 6 is 1, 0. So similarly you have to write the inputs. So in order to calculate x1 of 0, it is x of 0 plus x of 4 into W0. So it is 1 plus 0, 1. Similarly if you want to write x1 of 1, it is 1 minus 0, 1 minus 0 into W0. You are going to get answer as 1. Similarly you have to calculate for x1 of 2, 3, 4, 5, 6 and 7, and you are going to get all 1. Now these are going to act as an input for the second stage, these all. So in order to get x2 of 0, it is x1 of 0 plus x1 of 2 into W0. So x1 of 0 value is 1, x1 of 2 is 1 into W0. So the 1 plus 1 is 2. How W0 is 1 and W2 value is how much? So you can see here, W0 value is 1, W81 is minus 0.707 minus J 0.707, W2 is minus J, W3 is minus 0.707 minus J 0.707. So accordingly, so W80 ke liye you are getting 1. So if you are taking W82, you just need to write minus J, and accordingly you are going to get the answer. Here, in order to get x3 of 0, it is x2 of 0 plus x2 of 4. Right? In order to get x3 of 1, it is x2 of 1 plus x2 of 5. In order to get x3 of 2, it is x2 of 2 plus x2 of 6. x2 of 3, sorry, x3 of 3 is equal to x2 of 3 plus x2 of 7. So wherever you have W81, W82, W83, you substitute these values and you are going to get the answers for this. You need to multiply W82 value, W83 value, then only you are going to get the same answer. But at the same time, if you get 1 minus J 2.41, you will be getting the conjugate of this somewhere on the line. And here if it is 1 minus J 0.414, also here also you are getting the conjugate. So the output side is natural number. So you have to write the same order: 4, 1 minus J 2.41, 0, 1 minus J 0.414, 0, 1 plus J 0.414, 0, 1 plus J 2.414. So this is the final answer. X of k is equal to this answer. So whenever you are trying to solve the problem, you draw the structure, give the inputs, write what are the output of this terminal, these points. Then separately you start writing the equations. Looking at this part, stage 1 output, you write it in this way: x1 of 0, substitute this, substitute the value. Or if you can easily look at the values of these inputs and you can easily substitute, no problem. But You draw the structure very correctly with all the values, with all the arrows. Then calculate the stages separately. It will be easy for you to get the answer, so the final answer. Now, I hope you can solve the problem on DIT FFT for 4 point and 8 point, and also a problem based on circular convolution, which is very important. Now we'll be looking at decimation in frequency, the next topic. We have gone through DIT, now it is DIF. In this algorithm, the output sequence x of k is divided into smaller and smaller sequence. Again, the structure, the butterfly structure, is almost similar to the DIT. So here it is A and B. You're giving the same arrows. A is going down, B is coming up. This is the straight line A. Now here it is A plus AB. There is no WNR. WNR is after this point. Here it is A minus B whole into WNR. So please make sure that it is A plus B. This is A minus B into WNR. So in DIF, the input is natural order and the output is of bit reverse order now. So the same structure, signal flow graph for DIF FFT N is equal to 4. Stage 0, 1, 2. So the input is natural order, small x of 0, small x of 1, 2 and 3. Right. Now you have to join first line to the third line, second line to the fourth line, and third line to first, fourth line to second. So look at this. Look at the butterfly and look at this part. This is your 1x from here, right? You're giving these two arrows and you're writing 1 minus 1, and after this you're writing WNR value, that is W40. Similarly, you're taking this x minus 1 and you're writing W41. This is very simple. Whatever output you're going to get, these will be the inputs for this stage. So let's see, how do you calculate x1 of 0? So x1 of 0 is what? X of 0 plus x of 2. So I need to write x of 2 here. And x of 1 is what? Small x of 1 plus small x of 3. X of 2. So x1 of 2 can be calculated as x of 0 minus x of 2 whole bracket into W40. Similarly, x1 of 3, x of 1 minus x of 3 whole into W41. Here also, in order to find x2 of 0, it is simply x1 of 0 plus x1 of 1. In order to get x2 of 1, so x2 of 2, as I said, this is bit reverse order. x2 of 2 can be written as x1 of 0 minus x1 of 1 into W40. And this is x2 of 1, which is x1 of 2 plus x1 of 3. And x2 of 3 can be written as x1 of 2 minus x1 of 3 into W40. So I hope you have understood the structure. If you can understand decimation in time structure, butterfly structure, then you can easily understand decimation in frequency. And I'll be giving one simple problem on signal flow graph as an assignment. So kindly go through that. If you have any doubt, you can please feel to contact. Thank you.